Hey there! Welcome to this crash course on linear regression, where math meets magic and data finally spill all its secrets. Today we are tackling one of the classics in machine learning, but before you go, oh no, not another boring math lecture. Let me paint you a picture. Imagine this: you just inherited a fortune. Congratulations! And you're ready to buy your dream house. You walk into the market, but it's chaos. Prices are all over the place. A tiny shoebox in the city center costs more than a mansion with a pool in the suburbs. You're baffled. You need a strategy to figure out, why is that mansion so cheap? Is it haunted? Can you predict how much house you can afford with your budget? So, what do? You could try staring at the listings and guessing prices like you're playing darts blindfolded, hiring an overpriced consultant who'll confuse you with jargon like market trends and inventory elasticity. Or you could call in the big guns. Linear regression. That's right, linear regression is the Sherlock Holmes of data. It sniffs out patterns, connects clues, and gives you formulas so precise you feel like a math wizard casting predictive spells. But don't worry, you don't need to know calculus or wear a pointy hat. By the end of this video, you'll not only understand linear regression, but also use it like a pro to predict things like house prices, stock trends, or even how many pizzas your friends will eat at your next party. Spoiler, it's always more than you expect. So grab your coffee, get comfy, and let's embark on this hilarious yet educational journey to demystify one of the coolest algorithms in machine learning. Trust me, it's gonna be a lot more fun than staring at a spreadsheet for hours.
Alright, let's keep it simple. Linear regression is like connecting dots with a straight line. But it's not just any line. It's the one that best represents relationship between two things like house size and price. Think about it like this. If you eat more pizza slices, you probably weigh more. That's a positive relationship. Or if you sleep less before exam, your score might lose time. A negative relationship. Linear regression figures out how strong and what direction these relationships are using a formula. Y equals to beta 0 plus beta 1 into x, where y represents what we want to predict, that is house price, x indicates the independent variable, example house size, and beta 0, the intercept where the line meets the y-axis, aka the starting point, and beta 1, the slope, how much y changes with x. So, essentially, linear regression is being like a detective who connects the clues to find the ultimate solution, the prediction, but instead of magnifying glasses, we use math. Now let's make this fun. Imagine linear regression as a rookie pizza delivery driver. The first day, they are terrible, delivering pizza late, cold, or to the wrong address. But every time they mess up, they learn. They adjust delivery faster and more accurately. That's exactly how linear regression learns. It starts with random guesses for the slope beta 1 and intercept beta 0 and measure how wrong it was using the mean squared error. Yes, 1 by n summation I equals to 1 to n yi minus y hat I whole square. Here yi is the actual value, example true house price, y hat I is the predicted value, for example pizza delivered to the wrong address, n is the number of data points pizza delivered. Using an algorithm called gradient descent, it adjusts the slope and intercept step by step until it finds the best fit line that makes the fewest mistake. Think of gradient descent as the GPS guiding a rookie pizza driver to success. Enough theory, right? Let's roll our sleeves and predict house prices with Python. I promise it's easier than assembling IKEA furniture. Here's our plan. Create a simple dataset, house sizes and prices, train a linear regression genie, make prediction and evaluate the model. Let's jump into the code. We start with simple dataset. Think of this as your neighbor's house, small, medium, and one that's probably haunted because it's way too cheap. Our goal is to predict the price y using the size x. Basically, we're saying, size, tell us your secrets. Now, let's play fair. We train the model on 80% of the data and test it on the remaining 20%. This is like studying for a test but leaving some questions for surprise quizzes. Here comes our linear regression genie. We hand it to the training data and it starts learning the best fit line. Remember, it's learning like that pizza guy, making mistakes, improving, and eventually nailing it. Now, let's ask our trained model. Hey Genie, what's the price of these test houses? Let's see how close its answers are to reality. We evaluate the model's performance using the mean squared error. If the error is small, it's like a pizza guy finally delivering all pizza hot and on time. Let's bring this to life with a scatter plot. The blue dots are the training data and the green ones are the test data, and the red line is the genie's prediction, a straight road to house price success. And there you have it, linear regression in action. We connected the dots, predicted house prices, and even let our pizza guy graduate. Remember, linear regression works best when there is strong relation between variables. It's not just for houses, you can predict anything from sales to exam score. Thanks for watching, and if you like this video, smash that like button like gradient descent smashes cost function. See you in the next one.